Hey guys, welcome back to Chemchris TV. Good to have you here. Jamb exam is very close, and so many of you are asking, we should treat the reaction aspect of what organic chemistry. So in this video here, we have to focus on the reaction aspect of organic chemistry when it comes to what Jamb reaction. So I'll be studying past questions for the past 3 to 4 days, and to checkmate how Jamb usually what ask the questions and the exam format. So what I came across is that these are the areas Jamb normally focus their attention on. Alkenes, alkynes, alkanos, alkanas, and alkanos are what carbonic acid. So we have to look at each and every one of them in this video here, and areas and ways and patterns Jamb ask questions. So after that, we are going to look at some exam possible question and past questions. So, but I've therefore explained the concept for you, the type of reaction each what they undergo. So make sure you stick to the end of this video. If you have any question, only leave at the comment section. So let's get into it here. So first for alkanes, if you look at alkanes, alkanes is what is saturated hydrocarbon. Just and is what saturated because it's what is sp3 hybrid orbital. Right there. So is what is called saturated compounds. So all saturated compounds can undergo two main types of reaction. One, it can undergo what? Combustion reaction. Two, it can undergo what? Dehydration reaction or called elimination reaction. So the typical reaction in which what alkanes undergo is called what? Combustion reaction. Combustion reaction. And when we talk about combustion reaction, this is the reaction. This is the reaction of what? Of hydrocarbon with what? Oxygen. So we talk about combustion reaction. Combustion reaction is type of reaction in which organic compound will go or burn air to produce CO2 and water. So the products are only CO2 and water. That is, they only produce CO2 and water. So a good example where you have something like CH4 plus what? O2. Right there. CH4 plus what? O2. Giving you what? CO2 plus what? H2O. Now, what we want to get here is what balance the reaction. How many carbon do you have here? Here we have 1 carbon. How many carbon do you have here? Here we have 1 carbon. How many hydrogen do you have here? Here we have what? 4 hydrogen. How many hydrogen do you have here? Here we have 2 hydrogen. So we have to balance hydrogen. The way we can balance hydrogen is make it to be 2. So make it to be 2. So it's going to balance here. 4 hydrogen. 4 hydrogen. The next one to look at is the oxygen. Here we have 2 oxygen. Here we have 2 oxygen, 2 oxygen. So on the reactant side, we only have 2 oxygen. But on the product side, we have 4 oxygen. So here we have 2 and 2. Because here oxygen is 2. Because of this 2 here, the oxygen is 2. Making 4. So to balance it here, you have to put here. Right there. So this type of reaction in which alkanes undergoes. Right there. So I want to show you the type of questions you see in the exam. So let me show you one question here. Okay, now let's look at this question. So let's look at what this question. You see that in the reaction above, the hydrocarbon CXHY is. So in the sense that this is called combustion reaction. It's called what? Combustion reaction. That is, and the carbon react oxygen to produce CO2 and water. Now is what Jamb past question. So we want to pay close attention here. They say that which hydrocarbon is this? Do you understand? So now for you to know the hydrocarbon is for you to know what, because when we talk about CXHY. Now X means what? Numbers of what? Carbon atom. Y means what? Numbers of what? Hydrogen atom. So how do you get it? How do you get here? So now for you to be able to get it here, I need to look for what? Numbers of hydrogen and what? Numbers of what? Carbon. So if we have, because here we have CXHY. Now how many carbon atoms do you have? You have 5 carbon atoms. Right there. So that's my X is equal to what? 5. Right there. My X is what? Is 5. Because numbers of carbon atoms, because X means what? Numbers of what? Carbon atoms here. Yeah. How many carbon atoms do you have here? Here we have what? 5. Do you understand? The next is what? Is my Y. Y is what? Numbers of what? Hydrogen atom. How many hydrogen atoms do you have here? 6 times 2 is what? Is 12. So the hydrocarbon is what? C5H12. Now, which of the class of organic compound does this belong to? Is it alkane, alkenes, or alkyne? Right there. Now, if you look at alkane, let me just write this out. Alkane is what? Alkanes is what? CnH2n plus 2. Alkene is what? Alkene is what? CnH2n, right? Then alkyne is what? Alkyne is what? CnH2n minus 2. If you check it very well. Do you understand? So the numbers of carbon atom, if I should plug the numbers of carbon atom here, I will know whether it's alkanes, alkenes, or alkyne. Now, my n, remember n because of what? Numbers of carbon atom, right? So that is, my n here is what? Is 5. Now, let me plug 5 here. Let me see. So it will be C5H25 plus 2. Can you see that? So that the main reason why I'm placing it on here, because I want to get this in here. I want to be sure the class of compound it belongs to. If it's alkanes, alkenes, or what? Alkyne. And these are their general molecular formula. They are the general molecular formula of the alkane. This is what general molecular formula alkenes. This is the general molecular formula of the alkyne. So if I should place 5 in each of there, anyone that gave me this one here, then this is where it belongs to. Just as easy as that. So I'm placing n here. What am I going to get? CnH25 plus 2. We're going to be C5H 2 times 5 is what? 10 plus 2, 12, which corresponds to that one here. So you see that in the reaction above, the hydrocarbon CSH1 is it aromatic? It's not aromatic. Is it alkane? It's an alkane. Right there, because it was C5H12. Do you understand? Is it alkane? Of course, no. Is it alkyne? No. So the answer is what? Is B. Do you understand? Now, this is the type of reaction in which what alkanes undergo. They undergo what? This type of reaction they undergo. So now the first reaction in which alkane undergo is called combustion reaction. That is, you react it what? With oxygen to produce CO2 and water. You get. Then you now look at what? Balance what? The reaction. Do you get? Now the next one to look at, the next type of reaction I want to look at is what's called. So now look at what the reaction of the what? Of the alkenes. Now this is what common reaction. Now alkenes is one of the organic compounds that undergo what? Variety of what? Of reactions. So alkenes is what? Is an unsaturated hydrocarbon, unsaturated hydrocarbon that contain what? sp2. Idea. And they have what? A double bond. So what type of reaction which one alkenes undergo? Now alkenes undergo what? Electrophilic what? Addition what? Reaction. Electrophilic what? Addition reaction. So alkene idea, very important here. So all unsaturated hydrocarbon undergo what? Addition what? Reaction. And the main reason why they undergo addition reaction is because it's what? It's to break what? The pi bonds. So if for example here I have like CH2 double bond here, CH2 plus what? X2. Do you understand? Now this one is an alkene that have double bond here. They undergo addition reaction. That is, you are adding what? A subscript or a reagent to what? To a double bond. Now when you are adding it to a double bond here, the double bond actually will not convert it to what? To a single bond. Right there. So if you are adding, you have job here, how many of X do you have? You have 2 of X. So you add one here, you add one here to break what? The pi bond. Do you understand? So when that happens, you're gonna have what? CH2, here we have X, here we have X. Now this X can be anything at all. Just as I can have what? A reagent or a catalyst or any condition here. So these are things you need to pay close attention to. So what about alkenes? Alkenes and alkynes, they undergo similar reaction because now they have what? They are what? Unsaturated. Just like alkenes have what? A double bond. Alkynes have what? Triple bond. Do you get that? So we are talking about alkenes now. So we are going to look at what the type of reactions in which what alkenes undergo, the type of addition what reaction. And one of them is called addition of what? Of hydrogen. Addition of hydrogen. Now this is where you're adding what? Hydrogen to what? To alkenes. In the presence of what? Of PT palladium or what? Nickel catalyst. Now, for alkenes to undergo what hydrogenation, it need what platinum, palladium, or what nickel what catalyst. And the reaction is very easy. If, for example, you have CH2 double bond CH2 is okay plus H2 is okay. Now, because there's a double bond here, you can add what two atoms of hydrogen. So one will be added here, one will be added here. Now, but this reaction will undergo will occur in place of platinum catalyst or palladium or what nickel what catalyst. Do you understand? So up here. Now remember here we have two hydrogen here, right? Hydrogen flower of and hydrogen here. So one will be added here and one will be added here. Now when you add hydrogen to this point here, to this two carbon here, the what double what will disappear. Left what one, right there, the pi bond what will disappear. So when that happens, here we now have what CH3, CH3. You can see that now this hydrogen here that is 2 before, I've increased over to 3, and this hydrogen that is 2 before, I will increase to 3. Now by doing that here, you have removed one bond. That bond you remove is called what the pi bond. That is to break the pi bonds. So additional reaction always occur when you break what the pi bonds. Right there, you convert what unsaturated hydrocarbon to what saturated what hydrocarbon. That is called what hydrogenation what reaction. That is addition of hydrogen to alkenes to break double bond to get what alkenes. Just now that, so this is what the first type of reaction in short alkenes or undergo. You get. So if for example here I have something like CH3 CH double bond CH2 plus or H2, here we have what nickel. Right there. What happen here? One hydrogen should be added here, one hydrogen ought to be added here. So what do I have here? I have what CH3 CH2 CH3. So how do I get this one here? So the reaction will occur between these two carbons that carry double bonds. So one hydrogen should be added here to for one actually CH here. Now if you add one hydrogen, that becomes CH2. Add one hydrogen here, that becomes CH2. You break what the double bond. Do you understand? So this is everything about what hydrogenation. Do you understand? This is everything about what hydrogenation. And there are different ways in which what they can ask questions in the word in the exam course of Jamb. Idea. So let's move to the next one. Addition of halogens. Addition of halogens. So it's very easy. It's like similar reaction to what to the hydrogen. For example, you have CH2 double bond CH2 plus Cl2. What happened here? The same thing here. Just that this does not need what? This does not need any condition. It can occur on its own. You get. So one chlorine will be added here, one chlorine will be added here. So here and now what CH2 Cl CH2 Cl. Can you see that? So here we have what 18 is okay. Here we have what chlorine gas. So what will be the name of this guy here? The name of this guy is going to be 1,2-dichloroethane. Is okay. So these are the what they react. These are the react. They don't react more than this. Yet they don't want to react more than this. These are the what they react. Over when ask like this, CH3 CH double CH2 plus what BRO2. What will happen here? Now hydrogen BRO bromine will be added here. Bromine will be added here. Do you understand? So I now have what CH3 CH, here we have what BRO, CH2, here we have what BRO. Do you understand? So the name of this guy is called propene. That is what the name of this guy is. Propene. What is the name of this guy here? The name of this guy is called 1,2-dibromopropane. Do you understand? So that called the addition of what halogens. Can either be what chlorine or what bromine. So let's move to the next one. Number 3. Addition of hydrogen like called hydrohalogenation. It's called hydrohalogenation. Hydrohalogenation. And the common ones are what HBRO and what our H what Cl. Do you understand? So called hydrohalogenation. So when you're adding hydrogen halide or hydrogen bromide to alkenes, what will happen here? So now there's a rule in short you that guides the addition of what of hydrogen halide to the alkene right there, and that is called Markovnikov rule. So enough for you to be able to what add what hydrogen bromide or hydrogen chloride to what to alkenes. You must understand what's called Markovnikov what addition. So Markovnikov addition guides the addition of what hydrogen halide to alkenes or alkynes. So it's called Markovnikov rule. Now, what does Markovnikov rule state? Markovnikov will state that whenever you are adding hydrogen to what to alkenes, now this is what you should do here. You should always add hydrogen to the carbon atom with more hydrogen. You should what add what hydrogen to the carbon atom with what more what hydrogen. So always add hydrogen to carbon with more hydrogen atom, more hydrogen what atom. Very important idea. The bromine or chlorine can go to the carbon atom with what less hydrogen atom. Now let me give you an example here. If for example here you are adding what hydrogen chloride to ethene. Now if you look at ethene very well, if you should look at ethene, the two carbon atoms that carry what double bond, they have equal numbers of hydrogen right there. So Markovnikov rule does not actually play here because the two carbon atoms have equal numbers of hydrogen. So hydrogen can be added here, depending on where you want to add it to. Then chlorine can also be added anywhere. So if for example now if you should add hydrogen here we have CH3, right? CH3. Remember the double bond changed to a single bond, right? Then chlorine will be added to this other point here. CH2Cl. Do you understand? So the name of this one is called ethene. Ethene. Why is it called what? Chloroethane. Chloroethane. Very important. But now, what now happens when you now add a situation where the alkene have carbon atom with what different hydrogen atom? So, for example, here we have this one here. You have CH2, CH3, CH2 plus what? HB what? RO. What will happen here? Now, this is where Markovnikov rule comes in. Right there. Markovnikov rule will guide what? The addition of what hydrogen bromide to this one alkenes here that have carbon atom with different numbers of what carbon hydrogen atom. If you look at what the first carbon here, the first carbon have hydrogen, 2 hydrogen. And the second carbon atom have hydrogen, 1 hydrogen. Now, what does Markovnikov rule state? Markovnikov rule state that hydrogen is always added to the carbon atom with what? More hydrogen atom. Now, from that rule here, it means that hydrogen will be added to the first carbon here because the first carbon is having what? 1 hydrogen here. Do you understand? Why bromine will add to what to this carbon here? What happened here? This double bond will change to a single bond. So this is what will happen. So this will not be the point of the reaction. Here we have CH3, CH. Here we now B what RO. Then here we have CH3. Now let me explain. How do I get this here? Follow the Markovnikov rule. Hydrogen is added to this carbon atom here. How many hydrogen do you have here? Here we have 2 hydrogen. If you add 1 hydrogen here, what happens here? That change to 3. That's why we have 2 here. Now remember, whenever you add here, the double bond will change to a single bond. So that is the reason why there is no double bond here. We now have only single bond here. Now, because we have added hydrogen here to form CH3, bromine will now go to this carbon atom here. That is why we have this one here. And it's very important to give the name of the compound. So what is the name of this compound here? Now, if you are still having issues with naming organic compound, then there's no way you can do well in your organic chemistry. It's not possible here. So, but I've done a complete playlist on what nomenclature of the organic compounds. Now, the playlist is what focused on what nomenclature of the organic compound. So, I will advise you to go check the description below and go watch this video here. Now, we have what called the nomenclature of the alkanes, cycloalkanes, cycloalkenes, alkynes, ketones, aldehyde, carboxylic acid derivative, alcohols. They are there for you to, they are waiting for you to, in case you still have issues with what naming of the organic compound. You get. So what is the name of this guy? The name of this guy is going to be what? 2 bromo, 2 what? 2 bromo propane. 2 bromo what? Propane. So that is what the name of this compound here. So that is about what? Hydrogenation. You get. Now there's one thing I'll show here. There's one thing I'll show here. Addition of water. So when you add water to alkenes or alkenes, what will be the product of the reaction? So now look at something here. Now, in order for you to be able to what, to safely what, add water to alkenes, guess what? You need acid catalyst. Acid what? Catalyst. You need what? Acid what? Catalyst to be able to what? To be able to add what? Water to what, to the alkene. You get. So now when you have something like this, CH2 double bond, CH2 plus what? H2O plus what? H2O, right? Now what will be the product? Now for the reaction to be able to occur very well, you need what? Acid catalyst. Hi there. You need what? Acid catalyst. So this reaction can only occur when you add acid catalyst to it. Now when you add acid catalyst to it, guess what? This water will break it down into 2 components. Here we have what? H plus OH what? Minus. Hi there. H plus OH minus. Now what will happen here? Now Markovnikov addition will also occur here. Markovnikov addition what will occur here? How? Hydrogen is added to the carbon atom with what? More hydrogen. While OH is added to the carbon atom with what? Less hydrogen. Do you understand? So now let me explain it again. We are talking about addition of water. Now addition of water can only occur in the presence of what? Acid what? Catalyst. So when you are reacting water with any of the alkene, there must be what? H plus, that is acid catalyst for the reaction to occur. You get. So when you add here, understand that immediately you add water, your acid to the reaction here. This water will be broken down into 2 components, H plus OH what? Minus. So you only add the hydrogen first, and hydrogen is only added to the carbon atom with what? More or higher what? Hydrogen atom. While OH should go to the carbon atom with what? Less hydrogen what? Atom, right? But here there's no point of that because the 2 carbon atom here, they have equal numbers of hydrogen. So up here, hydrogen can be added here or any other point. So if you add hydrogen here, this is what I'm going to get. Here we have what? CH3, CH2, OH. Can you see that? Now, see, whenever you're adding water to alkene, the product is always what? Alkanol. The product is always what? Alkanol. Yes, the product is always what? Alkanol. It's very important. The product is always what? Alkanol. Alkanol. Yes, the product is always Alkanol. So what will be the name of this guy here? The name is going to be what? Ethanol. Ethan what? Ethanol. That is what? That is the name. Do you understand? So let's try another one. Take another example here. If for example here we have CH3, CH double bond, CH2 plus what? H2O. Now what happened here? Now remember, water will break it down into 2 components, right? Which is what? H plus OH what? Minus, right? Now what happened here? Hydrogen is added to the carbon atom with what? More hydrogen. While OH is added to the carbon atom with what? Less oxygen. So what happened here? So here we have CH3, CHOH, then we have what? CH3. Can you see that? Now the main reason why hydrogen is added to this second carbon atom here, because the first carbon atom here is where I want to add hydrogen, because why? The carbon atom have what? Higher hydrogen atom. 2. Why is it have only 1? So if you should add hydrogen here, that becomes CH3. The double change to a single bond. Why OH should not be added to this other point, right? That is it. So what will not be the name of this compound here? What will be the name of this compound? The name of this compound is going to be 2-propanol. Right there. 2 what? Propanol or propa 2 or. Do you get that? Or per 2 what? Oh, that is it. So that is called the addition of what? Of water. That is called addition of what? Of water. So you can see how the reaction look like. Now the last reaction I want to look at is what? Is the addition of what? Bromine in the presence of water. Okay, so let's look at what? Addition of what? Halogen in the what? In the presence of what? Of water. This is where it's not talking about bromine water or what? Chlorine what? Water. It's very important here. Remember, when we do something like this, CH2 double bond, CH2 plus what? Cl, right? Cl2. What will happen here? Chlorine will be added here, and chlorine what will be added here, right? So this is what you're going to get. You now have CH2, Cl, you will have CH2, Cl, right? Now, but what now happens when you are adding in the presence of water? In the presence of water, what will happen? So this one is a total different what reaction. So let me bring on that one. Here we have CH2 double bond, CH2 plus what? BRO2. It's okay. Now these two, this I call chlorine water will be formed here and bromine water will be formed. Now let me explain to you. Now, instead of this guy to react to this one straight, these two will react. So in the sense that chlorine gas and water will to react together to form chlorine water. So this is what will happen here. Cl2 plus what? H2O. Can you see that? Cl2 plus what? H2O. Same thing with other one here. Here we have what? BRO2 plus what? H2O. Now look at what will happen here. Now, like as if there is no water here, what will happen here? One chlorine will be added here, one chlorine will be added here. Finish, get your reaction. But immediately you add water, now instead of to react to this one straight, no, two of them will react to produce what? A different species that we added to what? To this one here. So this is what will happen here. Here we have Cl plus what? HOH. So remember, these two will react together to form HCl plus what? Now this one will form what? HOClOH. Please look up now. Let me explain it again. It's called substitution what reaction. It's called double displacement what reaction. In the sense that here we have Cl2 which was Cl, right? Plus water is what? HOH, right? Now these two, this guy, and this one will go out to form this other way here. Why this one is very easy. Now this guy will remove chlorine for this one here to form ACl. Now why this one? Because chlorine is out already with this other one here. Now this bond will break, one will break. Do you see that? So this and this one will go out to form ACl. Why this one will attach to chlorine? Now this is called chlorine water. It's called what? Chlorine what? Water. It's called what? Chlorine water. Please pay attention. It's called what? Chlorine what? Water. It is the chlorine water you now add to this other one here. Just and the same to this other one here. Here we have what? B what? RO plus what? HOH. Now hydrogen and BRO will go to form what? H what? B what? RO. Can you see that? H what? BRO. Now why BRO and OH will form together to form what? Bromine what? Water. Bromine what? Water. Do you understand? So now I've seen a lot of questions in the exam under this one here. You get that? So they ask you what will be the product of the reaction when alkene undergo bromination or bromine water or react with what? Bromine water. The bromine water they are talking about here is what? BROH. Do you understand? BROH. What the chlorine water they are talking about is what? ClOOH. It's very important to know this here. So now when the reaction happen here, let me wipe this place out. Now when the reaction happen here, now there's something you want to know here. Now these two will always react to form ClOH and what? HCl. Always understand this here. Do you understand? So it is the bromine water that is more useful, that you are looking at. So it is the bromine water. It is called chlorine water. Chlorine what? Water. Why is it called chlorine water? Because water is like this HOH, right? Now you remove what this hydrogen and added what chlorine. That is why it's called chlorine water. Idea. And the chlorine will now act as well as hydrogen. Do you understand? Chlorine is always added to the carbon with what more hydrogen. With what more hydrogen. That makes sense here. Chlorine will be added to the carbon with what more hydrogen. So if you are adding what bromine water or chlorine water or bromine water to alkene, now what we understand is here that chlorine or bromine is always added acts as what as hydrogen and is always added to the carbon what with higher hydrogen atom or more hydrogen atom according to what to the Markovnikov addition. Do you understand? So what happen here? Remember here we have CH2 CH2. The two carbon atoms are the same, so there's no really a problem here. So here we now have what CH2 Cl. Here we have CH2 OH. That is it. Do you understand? Now the same thing will occur here. The same thing will occur here. The same thing will occur here. Now here you have to have what BROH is okay. BROH and what HB what arrow. Now it is the bromine water you are looking at. Idea. It is what is the bromine water you are looking at. So bromine is always added to the carbon atom with what more hydrogen atom. While the OH is added to the carbon atom with what less hydrogen atom. So here we have what CH2 B arrow and what CH2 OH. That is it. So what would that be the name? So that is why it's very important to know how to name this compound here. It's very important to know how to name this compound. So the name is going to be 2-chloro 1-ethanol. Idea. Because the OH is the functional group here. OH is the functional group. So it's always carbon 1. So it's carbon 1. So here we have 1, 2. Chlorine is a carbon of we say 2-chloro 1-ethanol. That is the OH is a carbon number 1. And here we have 2 carbon atoms. So that's why it's called ethanol. But the OH is a carbon number 1. So that's why I say 1-ethanol. Do you understand? That is it. The same thing here is going to be here we have what 2-bromo 1 what ethanol. So when you have something like this, CH2 CH3 CH2 C is okay. Now because there is water here, H2O here, right? Before what chlorine water, so let it be ClOH. Can you see that? Now chlorine will behave like what? Chlorine will behave like what? Hydrogen. You understand? Chlorine will behave like what? Hydrogen. So chlorine will always be added to the carbon atom with what? Higher what? Hydrogen atom. It means that chlorine will be added to this carbon atom here that is carried 2. While OH is added to this carbon atom here that is carrying 1. Do you understand? So here we now have what? CH2 CH. Here we have what? OH. Here we have what? CH2 Cl. That is it. Chlorine is always added to the carbon atom with more hydrogen atom. So that is it. So what would that be the name of this compound? What would be the name of this compound here? The name of this compound is going to be what? 1-chloro. Now why is it 1-chloro? Yeah, chlorine is a carbon number 1. But first for the OH must have the lowest possible number. 1, 2, 1, 2. Right there. So that's why you need to because I don't actually teach nomenclature today in this class because it's going to take much of our time. So that's why if you don't know how to name organic compound, I've done a complete video on nomenclature of the alcohol. Although we are still going to look at alcohol again, so you can go check it out. 1-chloro 2 what? Butanol. 1-chloro what? 2-butanol. You get? So that will be the end of this class. That will be the end of this class.